Okay, for this presentation then we are going to carry out an inline splice repair. Now an inline splice repair is normally a temporary repair when we carry it out on the aircraft, and there are strict rules and guidelines on which systems you can or indeed cannot carry out this type of repair. As with any crimp practice, it is always mandatory that you check the relevant information in the standard wiring practices manual before you commence with the job. The two types of tools generally used for this type of repair are the Daniels 232 crimp tool, or an alternative is the Raychem 1377. For the purpose of this training, we are going to stick with the Daniels tool. Now, in using this type of inline splice, we can see we've joined the two ends of the cable here. They call it an environmental splice because once we've connected the two ends together, we then slide over this little heat shrink sleeve and we use the heat shrink gun to melt it down either side of the crimp, and then there's a resin contained in the little coloured bands either side of the heat shrink sleeve which will melt and environmentally seal the crimp itself. Now, as with most crimps, they come in various sizes. We have the largest size, which is the yellow banded crimp, which is for use on gauge 12 to 16 wires. The blue one is the medium, which is between 16 and 20 gauge, and the smallest one is the red, which is between 20 and 26 gauge. All that information is detailed on the crimp tool itself, and you can see the color code reflects and matches the environmental splices themselves. So for today's task, what we're going to do is we are going to go and use the yellow splice. Obviously, before we start any crimp procedure, we must check that we have the correct crimp tool and that it is within its calibration date. Again, if it's not within its cal date, you should not use this tool on the aircraft. This tool, like every other one, operates on a ratchet mechanism, which means when you start closing to release the jaws, you must close it fully and it will spring release. The back of the tool has a little locator which ensures that the crimp itself will be in the correct position prior to using the crimp tool. So for this one, we're going to use the yellow. And I find it easier just to close the crimp tool up slightly. We then insert the yellow crimp and then just get it aligned up very, very nicely in the correct slot. Now, we've already used the wire strippers and we've already used them to strip the cable to the correct length. And with most connections, it is the length of the barrel plus about 1/32 of an inch. We can now push the conductor in to the barrel itself and complete the crimp. When we've done this, we gently remove the tool and, looking at the inspection hole which is on each of the crimps, check that we can see the conductor and a little bit of the conductor protruding from the back. Now we've done this, we can proceed to connect the other side of the wire. Now this is a test presentation. If you were doing this on the aircraft, one of the things you should ensure prior to crimping the other terminal is that you fit the over sleeve onto the crimp first. If you don't, then you'll have to redo it all again or disconnect the wire from the plug to put the overboot onto the thing. So now we've done that, what I need to do is again, and this is fairly straightforward, using the locator mechanism on the tool. So the locator assists it to sit nice and gently in the back of the tool, and again I close it up nice and gently just to make it sure it's correctly aligned. I now insert the crimp or the conductor into the crimp and complete the crimp as before. We'll release the tool. Now we can now remove the completely crimped item. And again, we inspect it for any signs of damage and the fact that we can see the conductor protruding through the inspection holes. When we've done this, we can now go ahead and use the heat shrink gun to environmentally seal the crimp onto the connector. There are a variety of heat guns available. As we are doing this in a training environment, we do not have to use aircraft approved heat guns. If you're carrying out this task or any heat shrink task on board the aircraft, you must ensure that you use the correct heat gun, again as stipulated in the standard wiring practices manual. These get incredibly hot, and most come with a deflector to give you a good all-round heating effect on the crimp tool itself. So we're now going to turn the tool on. I'm going to wait for him to warm up. Be very, very careful because it will get extremely hot. And obviously when you're doing this procedure, make sure you keep your hands away from the heat gun itself. The actual crimp itself, the heat overbook should fit nice and snugly over the conductive element of the crimp, and we can see the two coloured bands. The actual crimp itself should fit in between the two bands. If possible, get it right in the middle, but as long as it's between the two bands, it should be fine. Now we've got this nice and hot, and very, very carefully push it in to the element. Now once the heat shrink goes, it should be free to rotate the elements round. And what we're looking for is at the very end, where the coloured bands are, we want to ensure that the heat shrink will not only shrink, but the resin will melt, and it's the melting of the resin that produces the environmental seal. Hence the term environmental splice. Now that's gone nicely, so we can now remove it in this test environment and switch off the heat gun. Now we've completed this task. It's a simple job of inspecting the work, and when it cools down you'll see that the heat shrink will give it rigidity, and the melting of the resin will give it the environmental seal. Don't worry if some of the resin starts to seep out from the end. As long as it has melted all around the wire, then we will have given it a good environmental seal. That now completes the presentation on an inline splice.